All right, and welcome back. We're starting a new unit here today, and the first lesson in this new unit covers atoms, ions, and isotopes. All right, so atoms are the basic unit of matter. Here we have one pictured. They have three subatomic particles, so three particles that make up the atom. First, we have a proton, which is symbolized with a lowercase p and a plus symbol right there. You'll see that a lot. Protons have a mass of 1 AMU. That's called the atomic mass unit. They have a charge of +1, and they're found in the nucleus. So here they are. These two red positively charged circles represent the protons in our picture. The second subatomic particle is the neutron, which has a symbol of a lowercase n and is 0. Why does it have that 0? Well, it has a mass of 1 AMU, so it's got the same mass, same size as a proton. But here's why it has that 0. It has a charge of 0, or a neutral charge, kind of hence the term neutron. Neutrons are also found in the nucleus. So here are those blue circles in the nucleus. Get no charge on them. They're neutral. Finally, then, we have the electron, which is oftentimes symboled E negative. They have a mass of 0. Now, when you take physics next year, you'll learn that that's actually not true. They do have some mass, but it's a tiny, tiny, tiny amount of the mass of a proton or the mass of a neutron. So for this class, we'll go ahead and call it 0. They have a charge of -1, and they're found in the orbitals that surround the nucleus. So you see our electrons here flying in circles around the nucleus. All right, so protons. What is the importance of the protons? The number of protons is unique to each element. So what does that mean? That means that protons define the element. Everything that has 2 protons is helium. So 2 was the number we looked at in the previous diagram of the atom. We looked at helium. It had 2 protons. That made it helium. If an atom of helium were to gain a proton or lose a proton, it would no longer be helium. It would be, again, if it lost a proton, it would be hydrogen, only 1 proton. If it gained a proton, now it has 3, it would be lithium. So the number of protons defines what element the atom is. We call this the atomic number, and it's symbolized Z. And it's always found on the periodic table, almost always on the top of the periodic table. So here is a square from the periodic table. You'll notice that number on top, so atomic number, that's 8 for oxygen. And the reason why that's 8 is because all oxygen atoms have 8 protons. So there's a picture of oxygen, the atom, 8 protons. There's the atomic number 8 telling us that Z is equal to 8. So unlike the number of protons, which is defined by the element, the number of neutrons in an atom is not always the same. And it doesn't always equal the number of protons. So some atoms of the same element can have various numbers of neutrons. When this is the case, we call them isotopes. So a very important term there, isotopes. And isotopes are 2 or more forms of the same element that contain equal numbers of protons, but different numbers of neutrons in their nuclei, which is plural for nucleus. So as an example here, we have hydrogen. Here are the 3 isotopes of hydrogen. We have hydrogen 1 with just 1 proton. We have hydrogen 2, which has 1 proton, 1 neutron. And we have hydrogen 3 that has 1 proton and 2 neutrons. So again, it's defined to be hydrogen because each of these has just 1 proton. But these are the isotopes because each of them has a different number of neutrons in the nucleus. This leads us to mass number. So the idea is that electrons have virtually no mass. Again, for this class, we're going to call them no mass. So the mass number of an atom is determined by adding the number of protons and the number of neutrons from the nucleus. So chemical formula there, protons plus neutrons give us the mass number A for any given. All right, so a couple of example questions here. First one, what is the element pictured on the left? So the element is defined by the atomic number, Z, which is the number of protons. So taking a look at the nucleus, we have 1, 2, 3 protons. Looking in the periodic table, the element number 3 is lithium. So 3 protons means you're working with lithium. Second question then, what is the mass number of the atom pictured on the left? So again, mass number is found by adding the protons and the neutrons. Looking in the nucleus, we have 3 of each, 3 protons, 3 neutrons, so our mass number is 6. So that brings us to isotope notation. Notation is a way to write which isotope of an atom we have. So what we do is we use the element, so X is whatever element you happen to be working with, and we put the mass number, so that's protons plus neutrons, A, in the top left corner, and we put the atomic symbol, Z, in the bottom left corner, or the atomic number in the bottom left corner, that's the number of protons. So for example, carbon 12 is listed like this. So there's the mass number 12, it's protons plus neutrons, and 6 because that is the atomic number, the Z, for carbon. All carbon have 6 protons. So just a quick heads up, when you're using isotope notation, a lot of times you won't be given both the atomic number and the mass number. In fact, the only thing you have to be given really is the mass number. You should be able to find out the atomic number just by looking at the symbol and finding it on the periodic table. So here's an example, lithium 7. Oftentimes you just be given the element symbol, lithium, and the mass number 7. And then it would be up to you to look on the periodic table and see that lithium is number 3. Okay, let's take a look at a couple of examples here. So hydrogen has 1 proton. That's what the symbol here tells us, but also what the H tells us. If it has a mass of 3, that must mean it has 2 neutrons. 2 plus 1 gives us 3. Magnesium 24. And that 12 right there tells us that there are 12 protons. Protons plus neutrons equal to 24. So 12 plus 12, there must be 12 neutrons as well. Here's carbon 13. Again, this time they didn't give us the Z number, the atomic number down here. That's okay, we can use our periodic tables. It's on the next slide. And you can see that carbon is atomic number 6. That means 6 protons. 6 plus what gives us 13? That would be 7. So there's 7 neutrons. Iron 57. Once again, they didn't give us the Z number down here, the atomic number, but if we look at the periodic table, we can see that all iron have 26 protons. 26 plus what equals 57? That would be 31. So 31 neutrons. Every once in a while, you'll see it written like this. The next chapter we do will be nuclear chemistry, and you'll see it written more often like this. That 205 is the mass number. So it's the number that you generally see top left. You see it written behind the atom this time. Same principles though. We find thallium on the periodic table, 81 protons. 81 plus what gives us 205? It would be 124 neutrons. And here's our periodic table. So hopefully you have this out beside you. And again, when we did iron, you can look at the atomic number there for iron. Iron is atomic number 26. All right, very, very important concept here. All atoms have an equal number of protons and electrons, and therefore all atoms have 0 net charge. That doesn't mean electrons can't be gained or lost. They are, often. When electrons are gained or lost, though, we don't call it an atom anymore. We now call it an ion. So an ion is a species that has gained or lost electrons. Atoms that gain electrons are called anions and have a negative charge. Think about it, they now have more electrons, so they should have a negative charge. Electrons are negatively charged. Atoms that lose electrons are called cations, and these have a positive charge. So again, hopefully that makes sense. If you're losing a negative charge, you're going to have more total positive charges because you now have more total protons. So up here are cation. So here is our atom in the middle. 1 proton, 1 electron is hydrogen. If we go this way, we make a cation. We lose an electron. We now have a positively charged ion. And if we go this way, we have an anion. where we have gained an electron. So this would be a negatively charged hydrogen ion. All right, so atoms in the same family or group, that's the column of the up and down column, they tend to lose or gain the same number of electrons. So we look at the column here next to noble gases. These are the halogen. This is fluorine, chlorine, and bromine. They all tend to gain one electron. That makes them a -1 anion. The oxygen families, so the family with oxygen at the top, they all tend to gain 2 electrons. They would have a -2 charged on them. If we flip over here, this first row, column number 1, they all tend to lose 1 electron and form a +1 charge. So these charges are what we call oxidation numbers, and we'll work a lot more with those guys in the coming chapters. So cations are usually on the left side of the periodic table. We just took a look at that. When you're naming a cation, the word ion is added, but otherwise the name doesn't change. So the way that we find the charge of an ion is you subtract the number of protons by the number of electrons. Remember, the number of protons can't change. That's what defines what element it is. So subtract the number of electrons. Na+, that's a sodium ion. We know that it's 11 protons. All sodium have 11 protons. We know that we have 1 more positive charge than negative charge. So we must have 10 electrons. Magnesium, 2+. Magnesium ion, again, we can look at the periodic table, find the atomic number, 12 protons. This time we know that we have 2 more positives than negatives. Protons are positively charged, electrons are negatively charged. If we have 2 more protons than electrons, that must mean that a magnesium ion has 10 electrons. So moving on to anions then, these are on the right side of the periodic table. They're usually nonmetals and they tend to gain electrons to form a negative charge. So kind of a little trick here, the name changes. As I told you before, with the cations, the name doesn't change, we just add the word ion. When you're working with an anion, the ending changes. So for instance, oxygen is not oxygen ion, it's oxide ion. We add the IDE. We drop the ending and add the IDE. So some examples then. Here is fluoride ion. We know that all fluorine have 9 protons. We have 1 more negative than positive. So we have an overall net negative charge. So we must have 10 electrons on a fluoride ion. S-2, sulfide. So there's that IDE ending. We know that all sulfur have 16 protons. We have 2 more negative charges than positive charges. So 16 plus 2 equals 18 total electrons. Again, a quick little bit of practice again. Here's a sodium ion. Again, we've got the mass number up here, the atomic number there. So the number of protons is 11. The number of electrons would be 1 fewer because we have a positive charge. The number of neutrons would be 12. 12 plus 11 gives us 13. All right, Cl-1, it's a chloride ion. So the negative charges, we change the ending. All chlorine have 17 protons. 17 plus what equals 36? That'd be 19. So that's how we determine our number of neutrons. Electrons then, we have 1 more electron than proton. That's what the -1 here tells us. So 18 electrons. Br, -3. So Br is bromine. We're going to drop the ending and add the IDE, bromide. All bromide or all bromine have 35 protons. It's the atomic number. So it defines the element. The mass number is 35 plus number of neutrons. So 35 plus what gives us 80. That would be 45 neutrons. And then because there's a -3 charge, that means there's 3 more electrons than protons. So there's 38 electrons. And finally, magnesium-27 with an ion there. Protons, 12, all magnesium have 12 protons. We have 2 more positive charges than negative charges. So our electrons are 10. And then 12 plus what? is equal